Okay, for today, what we're going to talk about is we are going to be talking about symmetry of a particular function. So you can identify the type of symmetry that you have in functions. So here we go. Let's talk a little bit about it. There's two types of symmetry. Actually, there's several types of symmetry, but one of them is there's what they call linear symmetry or line symmetry. So there's line symmetry, right? And then the other one is point symmetry. So we're going to look at it line versus point. Okay, so it's going to be line versus point. And using that same idea, we say that there's line versus point. You can also say that if you have line versus point, one could also say you have reflection versus rotation. And that's one thing that you can relate this to is reflection versus rotation. And then you have the other part, besides being a line, reflection, uh, symmetry, there's also what they call it being even. And then the other one is what they say is odd. So we're going to get into this right now. So you have those types of scenarios. So the idea of reflect linear symmetry is that a line can be folded um, along, or a graph can be folded, and you can put it in your pocket. So like this guy right here, I could fold it right there and put it in my pocket. I could fold this one right here and put it in my pocket. I could fold this right here and put it in my pocket, right? I could fold it along this line right here and put it in my pocket. Those are what it's like to have linear symmetry, right? Typically, you either have the y-axis or the x-axis. You also sometimes have along the line um, like a y equals x line, the identity line. The other type of symmetry you have is called point symmetry. That is, if you were to punch it, it would flip. If I punched this guy right here, it would spin and it can go, and it's the carbon copy of it. Same thing right here. This is point symmetry. Typically, point symmetry is that with respect to the origin. Now, how can you test if this is true if you have line versus point? All right. Graphically, graphically, um, if you have for every x comma y, if the point x comma negative y is on there, then you have some sort of symmetry, and that would be the symmetry along the x axis. Algebraically, you replace y with negative y, and if you get the exact same equation, then you have linear symmetry. We have symmetry with respect to the x-axis. When you're looking at the y-axis, then what happens is if you take the point x comma y, actually I'm going to use a different color here. If you do x comma y, and when you replace it, if you get negative x comma y, if negative x comma y is also on the graph, then you have linear symmetry with respect to the y-axis. One would argue that if you take the letter x and you replace it with negative x, then and you get the same equation, then you're going to get linear symmetry. As far as origin or rotational symmetry, what you got to do here, and I'm going to erase this, for rotational symmetry or point symmetry, if you're going to do point symmetry, what you got to do there is a little different. For point symmetry, um, ideally, what you're going to do here is if you replace the x comma y with the negative x, negative y, if that is also on the graph, then you have the reflection along a point or rotation. And then if you replace in the function, if you replace x and y with negative x and negative y, that's how you do it algebraically. And we'll have a little bit of an example of this in just a bit. Okay. When we talk about even or odd, all right, even or odd are the other types of functions. Even functions, right? Even functions, this is important right here. F of negative x is equal to f of x. Even functions tend to be symmetric with respect to the y-axis. Okay? Odd, this is important right here. Odd, if you plug in negative x and you get the opposite of the function, then you have reflection or rotation symmetry. All right, so you can kind of see that you can punch it, flip it, and it'd be the exact same thing. So that's kind of like these similarities. Now, how do you do this algebraically? We talked about that. How do you prove if a function is even, odd, or whatever symmetry? If we have a function like f of x equals x cubed minus x. All right. One thing, if I replace f of x with f of negative x and I get the same thing, then I will probably be I'll be an even function and I have linear symmetry. But let's see what happens if I do this. If I plug that in, I get negative x cubed minus a negative x. Negative x cubed is going to give me negative x cubed, and this is plus x. So what happened? I don't know. Well, if I take the function and take all the opposites, this is going to be negative x cubed plus x. There it is. F of x is equal to negative f of x. Then this is an odd function, and so it has symmetry with respect to the origin, or rotational symmetry. Okay, kind of maybe not quite get that too good. Let's look at something a little different. Let's look at a different function. How about f of x equals negative x squared plus 6? Do the same thing. If I replace the x with a negative x, let's see what happens. Here, and then I go negative x squared plus 6. Well, what's negative x squared? Negative x squared is positive x squared. Then this becomes negative x squared plus 6. Well, you see f of x and f of negative x are the exact same thing. All right, no sweat. That's even. And that means that I'm symmetric with the respect to the y-axis, so I have linear stuff. Another nice thing is you could graph them and see what it looks like. So this was real easy. It wasn't super tough. Hopefully that makes sense. You got plenty of practice you can do on this. And I look forward to seeing you in class. And may the force be with you.